Hi, welcome to this introductory section of Basic Electronics. We are going to deal the subject with simulation to make it more clear for all of you. Now let me start with very basic fundamentals. Like supposing if I take a battery, I keep the battery here. Now let me zoom it to an extent so that all of you can see it better. And I take suppose a LED, and I have an LED here, and we all know that a LED requires always a series resistor. So I take a series resistor, I put a series resistor here and connect it here, and let me put a switch also for that to see its function. Connect it this way, I connect it this way. Now all of us know that when we give this switch, this LED is going to glow. And so let me see that. So when I put this switch, the LED starts glowing. How? The current starts flowing from here through this, here, through the resistance, through the LED, and then reaches here. That means it must start from this place and end at this place. This is called the path. Unless the path is complete, the load, whether here is a LED, is not going to glow. So this is the very basic fundamental that we must know, how the path is complete. Let me repeat it again. That path means it has to start from the positive and reach at the negative, right? Or in most of the electronic circuits we do not have this shown like this, but then what we do is that we provide it a ground connection and give a ground here and here and give a ground here and here, and even then this circuit is also same as what we had seen earlier. Now if I switch on this, it also glows. The operation is same. That means the current goes from here, 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 here. This and this point being common, that means they are internally connected. It goes this way, this way, this way, and this way. And don't be under the impression that this current will flow to the ground. There is nothing like ground in electronic circuits. It is only a word used in place of battery negative or DC negative. For example, if we delete this ground and if I give power, it doesn't glow because the path is not complete. It has to start from here, 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 here. No, it is not going anywhere. There is nothing like ground. It has to reach here. Because it is not reaching here, so the path is not complete. So this is the very basic fundamental of understanding how the path concept is achieved. Next we go over to some kind of very simple operation that we all know is a voltage divider. What is a voltage divider? A voltage divider, for example, we take some 10K resistor and I put a 10K resistor here, another 10K resistor here, and connect it this way and connect it to this way. And as usual I said I must have a ground connection for the path to be complete. I put the ground connection here and I give this to this, and I know this is a 12 volt supply, and I have connected two 10K resistors in series like this. That means, okay, let me now remove this ground to make you more clear understanding that okay, now the path is complete. I can see that the path will be complete only when I switch on this. Now let me assess as what will be the voltage here. Here means, the moment I say here, meaning that with respect to negative or with respect to ground, what we can also have a connection like this. We can show it this way. So if I say what is the voltage here, I mean that what is the voltage with respect to ground. Okay, let us zoom it still further more. Okay, right. Now let me take a voltmeter. I connect a voltmeter here, and let me connect this to this place and connect this to this place. As we know that this is a 10k resistor and this is a 10k resistor, and my supply voltage is 12 volt, and when I switch on this, the voltage, half the voltage will be here and half the voltage will be here. So obviously this will be 6 volts. Let me see that when I simulate this. Yes, I get 6 volts. Is it clear? I get 6 volts here. So because I get 6 volts here is just because there is a ratio of 1:1. Normally what you would have done in electrical engineering or electronics engineering, what you read is that, okay, you say that 10k is total 20k, 12 volt divided by 20k is the current which is flowing, then the I into this R is equal to voltage drop across this, then I into R voltage drop across this. All this is as far as the real calculation is concerned, but in practical electronic circuits you must be able to guess the voltage. Guess the voltage in the sense that you should know as to what will be the voltage approximately here. Now if that was a simple calculation, now let's go over to say, let me make this voltage, okay, let me make this resistor as say 8k, right, and make this resistor as 4k, right. Now what will be the voltage here? Think in those terms only. See, this is 8k, this is 4k. That means this is 2 times of this. The total ratio, total is about 3. So 12 divided by 3 is 4, and 4 into 1 is 4 here, 4 into 2 is 8 here. That means this voltage will be 8 volts and this voltage will be 4 volts. That's the way that we should understand. Now let's put it in this way and see. Yes. So we are getting it exactly 4 volts here. But we can see. Sorry. So we see that it is 4 volts here. Oh, it goes away to that side. Okay. Right. So you can see it. There is a 4 volt here. So like that you have to calculate in approximation as to what will be the voltage at a particular point. So that is very important when you are handling practical circuits, and you can't go into calculations of that nature. Actually in the marketplace you perhaps will not be able to get a resistance of 8k and a 4k. It will be somewhere because their resistances are at particular standards. So the market value will be about say 8.2k, and the closest value to 4k is 3.9k, right. So this is what the voltage. Now if somebody is asking you what is the voltage here, you have to just guess. It's not necessarily that you have to be very close, very accurate, but you can be very close to it. I know because this 3.9k is really close to about 4k, and this is close to about 8k, so it will be somewhere near 4 volts. Now let's see what is the voltage. Yeah, voltage is 3.87. So this is what is that one has to understand the potential divider in terms of its ratio, right. And now next move that we would like to go for understanding a variable resistor. What is a variable resistor? A variable resistor is we call potentiometer, which is got maybe 3 terminals, and this is what is called a variable resistor. Okay, this is a variable resistor. It has got 1 point, 1 point and 1 point. Typically they are round in shape when you look it in the physical way, but when we represent it in a circuit way, it is given like this. Okay, now what I do now, okay, let me disconnect this connection, disconnect this connection, and bring it here and put it here, and let it be say my 4k, and let this be what I had gone earlier, let this be 8k, Alright, now what I do is I give the connections what we have done. So I give this connection to here, I give this connection to here, and I give this connection to here. Now let me see how the voltage is behaving in a voltage divider situation. I know if this is 12 volt and this is 8k and this is 4k, that means at this point the voltage will be 4 volts. At this point the voltage will be 0 volts, right? So let's see, and at this exactly at 50% the voltage will be half the voltage of 4 volts, because the total voltage drop across this is 4 volts. So this will be half the voltage. Now let's see, while we power it, I get exactly 2 volts here. Now if I go on going up, I see the voltage is going up. Now here it comes to 4 volt. When it comes here, it is 4 volt, or when it goes down, it goes to 0 volt. So this is how a variable resistor can be used for getting variable voltage as per our requirement. Sometimes we require such kind of arrangement where a particular voltage needs to be given to certain circuit. So that is how the potential divider comes into real picture. Now next, after understanding the potential divider, let's see that how we use sometimes a variable resistor in a little different fashion. Like for example, I delete this, and what I do is, okay, I take this connection and give it here, and give it say here. Now let me see what exactly the situation here. Now this resistance is 8k, but this 4k resistance is now half of it is bypassed. You can see half of it is bypassed. That means the virtual resistance of this, the actual resistance of this is about 2k. That is from here to here, because here to here it is bypassed. So it's a 2k resistance. That means 8k and 2k. In that ratio it will come. That ratio means 8k, 2k. This is about how many times? 2k is about 6 times. So how much voltage will I get? I get 2.4 volts. And when I change it this side, the voltage goes on falling and ultimately goes to 0. That means I am able to vary it from 0 to 2.4 volts. And if I go on above, and then I get 4 volts. This is also another arrangement where I can vary the voltage in this fashion, right? So this is how the potential divider or a variable resistor can be used for specific requirement of voltage. Now, having seen all this, let's go over to some very simple circuits that we will be using in our projects. Now let us remove all this. Let's have the meter only, and let me take a transistor. Now let's say if I take a transistor here, this is a transistor, and then let me connect this. Okay, sorry, we go to a LED again. Okay, let's connect an LED here. I connect an LED here, and I connect a series resistor. As I have always said that the resistance is a must in case of any LED that I am going to use. So I put a resistance here, and this goes to ground, and this is, supposing I put one more resistor here, and I put it in a way that I should be able to connect it. I put it this way, give it a connection here, and give it a connection here. Now let us zoom it so that all of you can see it better. Oh, not coming. Okay, so I take it this way. Sorry. Right, now it's visible. Okay, now let me analyze this circuit. Now, okay, connect the voltmeter also here. We'll see what is happening when this is powered. Okay, now when I power this, I know there is a leak. There is absolutely 0 volt here, and then when we switch on this, what happens? That this LED glows this way. How? Transistors, in most of the cases, what we will be using in our projects are used as switches. Transistors have got several other features, but in all our projects, most of our projects will be using transistor as a switch. Let's understand how this works. Now when I apply the power, the first current flows this way, 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 this way. That means the base to emitter, the current flows. This is an NPN transistor, and in an NPN transistor the current has to flow from base to emitter for the collector to emitter to get switched on like a switch. So what happens? So when the current flows this way, this way, this way, this way, this way, this way, and this way, and this, then only this current starts flowing this way, this way, this way, this way, and this. And once the current starts flowing between this is, as I said, these 2 points are just like a switch. Just like a switch means once the switch closes, the voltage drop across this is nearing 0. Just the switch drop, or the saturation voltage drop we call it. And so since this particular point comes to ground, because this particular point comes to ground, it is nearly 0 volts. So this is what a transistor is used like a switch. Now let's understand a little more about it. That means when this current is flowing between base to emitter, then only the current will flow from collector to emitter in the direction of the arrow. That means this current will flow this way, and this current will flow this way, right? This current will flow this way, and this current will flow this way. So this is what the way that the transistor is operating on a switching function. Now when this current flows from here to here, when this side is high and this being low, low means negative. So when this is high, then only the current flows. So, and at that situation, this point becomes low. That means since this point comes to ground, so this becomes low. That means when base is high, that means when this point is high, this point is low, and when this point is low, this point will be high. We can see that. Now supposing I do not pass the current through the gate, through the base. Now let's see. You see, if I do not pass current through the base, there is no current flowing. There is no current flowing here, nor no current is flowing here. So what is happening? I am getting the full voltage here. That means this is the open circuit voltage, or I call it high. So when now this is low. Low means there is no current flowing here. So this is low. So when this is low, this is high, and when this is high, this is low. That's what we have seen. Now we will connect it again. Okay, I connect it again and see what is happening. See, now this current flows this way, and this current flows this way, and that is how the switching function of a transistor is achieved. In most of your projects, we'll be handling switching functions like this. Well, we will be using another component which is called a relay. You know, a relay typically is a component. Okay, a relay is a component. Let me bring a relay here. Okay, this is a relay. This is a relay. So for seeing it better, let me zoom it to an extent so that all of you can see it better. This is a relay. A relay has one coil, a coil of several thousand turns over an iron piece, and when the current flows through this, whether this direction or this direction doesn't matter, when the current flows through this, there is an isolated switch. We call this an isolated switch, and it has got 3 points. One is a common point. This is called common point. This is called NC point, that is normally closed. Normally closed means when there is no power given, this is in this position, and when the power is given, this switches from this to this. Now let's see how it really behaves. Now okay, so what I do, I take a battery. I take a battery, I put the battery here, and okay, I take a switch. Put a switch here, and connect this to this, and connect this to this, and connect this to this. Right? Now let me see how the relay is really working. Right? Now when I give power to the coil, you see this point, no power, power, no power, power. So this point is a switch which can be utilized for any purpose, and let's see how we utilize it for some purpose. Okay, we go back to the same circuit that we have at the top, and we will replace the transistor with a relay. Now let's go over to this, disconnect this, and disconnect this, and what I do is I take a relay, I put the relay here, right? And okay, if you are not able to see it better, let me zoom it, right? And what I do is I take this positive supply. With the obviously this is positive supply. When the switch is closed, this positive supply is available here, and I connect this to this. Alright, now let's see how it behaves. Now, right. That means, right. So what we have seen here, that only when the current flows in the base to emitter circuit, then only this switch closes, we have discussed. So after the switch closes, this current flows this way, and the path is complete. And that is how this switch changes to this side. Right? Let's operate few more types. Right? You look at this. So this sort of arrangement can be utilized for certain other activities also. For example, if I take an AC supply, say I have a AC supply, and let me take a lamp, supposing I put all of them in series, the lamp, AC supply, and what I do is I connect here, and let me connect this, right? Now what we find here, we find there is a AC supply, there is a bulb, and I have connected in such a fashion, we will see how it behaves. Now for certain simulation purposes, let me call this lamp as 12 volt, okay, and supply also I can take any voltage based on the lamp, but then I will also make it the same voltage. It can be 220 volts, it can be 300 volt, 400 volt, whatever, because this switch is nothing to do with this supply. This is completely isolated, and we call it magnetically coupled. That is why this actually the relay is called an electromagnetic relay. It's not a normally people call it a relay, but it's an electromagnetic relay. Some people have a confusion or a misinterpretation that the relay is a protection relay. Relay actually is not a protection relay. Protection is incidentally is one of its activities, but actually the relay is used for this kind of purpose. Okay, now let's again power this. Let's see what is happening. We have the AC supply available here, but this lamp is not glowing. Why? Because the path is not complete. Okay, it goes here, goes stop. It can glow only when this changes to this side. Now we'll see this. Now let's use this. You see, now the lamp starts glowing. Why the lamp starts glowing? Is because this switch has come to this side, the path is complete. Once the path is complete, obviously the lamp will glow. Now see it few more times, this way, this way, this way. So this is how we use a transistor as a switch to switch on another load which is completely independent of any supply. This could be a low voltage supply, this could be a microcontroller supply, this could be something, but then this could be any higher voltage, AC voltage, DC voltage, whatever it is that we choose. So this is how a relay is used in switching on an arrangement like this. Actually, in certain electronic circuits we use number of relays. When we use number of relays, obviously we will be using number of transistors, and then the current which has to flow in the base also has to be coming from some other source. Those are all details we will be discussing little later. Now let's, instead of this, now supposing I would like to go in for some kind of arrangement where I will run a motor. Okay, now let's stop this. Now I close this. Okay, I stop this. I take another set of battery or a DC source, whatever it is. Now let me take another source of battery here. Right. Okay, I connect it to this place, and I take a motor. Say for example, I take a motor here. Right. I connect this to this, and I connect this to this. Right. Do it little more again. Okay. Now let's see. Now in the same fashion, when I power this, okay, there is some simulation difficulties here. Okay, so we will go these sort of things little later. Okay, so this is what we understand, that how a relay is used in our circuits. Now we will go over to one more important component, which is called operational amplifier. We will be having separate audio for this, but let me give an overview of how an operational amplifier works, because we will be using in most of our projects operational amplifiers also. Okay, now let's delete all this and see how we use an operational amplifier. Let me have the switch and battery connection as it is, and let me go over to an operational amplifier. I take an operational amplifier like this. Okay, and as usual, I have to give a supply to the operational amplifier. I give a supply to this like this, and I think one sec. Right. So what we have taken a so we go over to like this now. So we give a supply to the IC, positive, negative, and then we know that operational amplifiers can also be used as comparators. What is a comparator? A comparator is that when plus right. So what we were talking about an operational amplifier. An operational amplifier, we know it has got one non-inverting input, one inverting input, and one output. And such kind of operational amplifiers, in fact, in ICs are available either one operational amplifier in an IC, two operational amplifiers in an IC, four, like that. We have taken, for the convenience sake for our understanding here, one of the four operational amplifiers in a IC called LM339 or LP339. Okay, now let's see how it behaves when we start using it as a comparator. What is a comparator? A comparator is that, let's call it that if this is non-inverting input and this is the inverting input, and since this is denoted by plus and this is denoted by minus, so let me for convenience call it plus and minus. And the formula for the comparator is that when plus is more than minus, output is equal to 1. 1 means that the supply voltage. If the supply voltage is 12 volt, that means the pin number 3 I have given 12 volts here. So 1 means in the output 1 means it is 12. Okay. So now let's go over to certain connections for it and let's see about it. Now let me take a say a 10k resistor and I connect this resistor here and connect this resistor here and take one more resistor here and then connect this to this and connect this to this. We have seen that is the potential divider of 10k and supposing I give it to this point, I know this point will be now, if this is 12 volt, this point will be 6 volts because it is half the voltage based on this potential divider. Now let me take a variable resistor. Okay, what is a variable resistor? Okay, this is a variable resistor. I take a variable resistor and I take a variable resistor here and let me connect it this way. That means the upper side is connected to 12 volt, bottom side is connected to ground. So that means when I vary this, this point can go to 12 volts or it can come to 0 volts, right? So let me make it at this point. I know this will be half means 6 volts. So let me keep it slightly more than this, right? And now I connect it. Okay, if you are getting confused, so let me take it in a angle way so that you will not be confused. Right. Now this potential divider which is above little 6 volts I have connected to here, that is plus terminal, and this I know is 10k and 10k, it is bound to be 6 volts. So that means this will be 6 volts, this will be more than 6 volts, output will be 1. Whether output is 1 or not, let's connect again a resistor here. Okay, let's connect a resistor in certain typical style, right? Connect a resistance here and let me connect a meter also for that to see the voltage. I connect a meter here, I connect this to this point and this point to say this point, right? And connect this to ground. Look it a little better. Let me do it. Okay, let me do it this way and this way. Now looks nice, right? So what is the function? Okay, this is a 10k resistor as we know. Now let's power this and see what is happening. You see, now we know that this point is, if you want to know exactly what is the voltage here, I can connect some voltage probes here also. I put a voltage probe here, give a connection from here to here, and another voltage probe here and give a connection from here to here. Okay, now let's power it. You see, this point is at 5.9933, means is close to about 6 volts, and this point is 7.19 volts. That means this point plus is more than the minus. Output is equal to high. High means 1. 1 means supply voltage. Now if this changes to this, that means this becomes 4.7 volts. That means plus is less than the minus, so the minus remains same. When plus is less than the minus, output is equal to 0. So this is what is the basic function of an operational amplifier used as a comparator. We will see these functions in more detail when we go over to certain more complicated circuits. So this is what is the concept of using a potential divider, a relay, a transistor, an operational amplifier, and so on. So let's now clean all these and let's see how we go over to some more fundamental things which will be more clear. clear, right?